Alright, let's go. Number 10. The Drowned Valley of Kufra. A river system larger than the Amazon once drained into the Mediterranean from the middle of what is now the Sahara, and the only reason we know it existed is because a radar signal passed through the sand. In November 1981, the Space Shuttle Columbia flew over the eastern Sahara carrying a synthetic aperture radar system designed to image surface geology. The instrument was not pointed at sand dunes, it was calibrated to penetrate them. Mission specialists at NASA's Jet Propulsion Laboratory in Pasadena had configured the L-band radar to reach roughly 2 meters beneath the surface, expecting to find bedrock. What they found instead were the curved, branching signatures of river channels, wide, meandering, unmistakably fluvial, running for hundreds of kilometers beneath the Libyan desert west of the Sudan border. The team called the network the Radar Rivers, and the largest of them, which drained toward what is now the Gulf of Sidra, would have been one of the great watercourses of the ancient world. The anomaly was not the channels themselves, it was their size. Dr. John Macaulay of the U.S. Geological Survey, one of the primary analysts on the radar data, published preliminary findings noting that the buried paleo-drainage network beneath the eastern Sahara was consistent with a sustained humid period lasting thousands of years. The main channel measured over 8 kilometers wide in places, wide enough that standing on one bank, a person could not make out the opposite shore. The sediment deposits surrounding the buried channels were lacustrine, meaning they formed at the bottom of standing water. The implication was not a seasonal river. The implication was a permanent, navigable waterway cutting through the center of a region that now receives less than a centimeter of rain per year. What made the conventional explanation insufficient was not the existence of the channels but the depth of the sediment sitting above them, undisturbed for a period that the initial analysis could not confidently bound. The shuttle radar data entered public knowledge through a 1982 paper in Science co-authored by Macaulay and several colleagues from JPL and the USGS. The press coverage focused on the technology, the satellite that could see through sand, rather than the implication of what the sand was hiding. The version of events most people received was a story about remote sensing capability. The version the data was telling was a story about a continent-scale hydrological network that no longer exists. The radar rivers were officially incorporated into the paleoclimate literature under the framework of the African Humid Period, a climatic interval now dated roughly between 11,000 and 5,000 years ago. The reclassification was gradual, absorbed into a body of literature rather than announced as a discrete finding. The conclusion that a major river system had once connected the central Sahara to the sea was confirmed without ceremony. But the buried channel network beneath the Libyan desert remains wider than the Nile at its broadest point, and it fed a watershed that at its maximum extent covered an area larger than the continental United States west of the Mississippi. The African Humid Period model accounts for this network's existence. It does not yet fully account for how quickly and how completely it stopped. Number 9. The cattle herders of Tassili en Ager. At an elevation of over 1,000 meters in the central Algerian plateau, thousands of painted figures show human communities doing something that should be impossible in a desert, running livestock through green, watered land. The Tassili en Ager Plateau in southeastern Algeria rises sharply from the surrounding erg, its sandstone formations eroded into shapes that resemble a ruined city scene from a distance. French explorer Henry Lotte reached the plateau in 1956 leading a team of artists and documentarians sent by the French National Center for Scientific Research. Over the course of 16 months, the team traced and recorded over 800 individual painted compositions from the sandstone walls of the massif. Lotte's crew worked in extreme heat, carrying water up cliff faces, pressing paper against painted surfaces to capture the outlines of figures that had been sealed inside rock shelters for thousands of years. They found cattle. They found cattle in enormous numbers, herded, branded, decorated with tassels, shown in the company of human figures who were clearly tending them with care. The anomaly was that the rock art showed not isolated cattle but complex pastoralist communities, with scenes of milking, herding, and what appeared to be ritual gathering around animals in spaces that were unmistakably depicted as open, green, and well-watered. Dr. Alfred Mussolini, a specialist in Saharan prehistoric art affiliated with the University of Toulouse, later conducted detailed stylistic and chronological analysis of the Tassili corpus and identified a distinct period, which he dated to between roughly 7,000 and 5,000 years ago, in which the imagery shifted from wild animal hunts to scenes of domestic cattle management. In one shelter at Sahara, a single continuous composition spans nearly 30 meters of wall and shows a cattle herd numbering in the dozens, supervised by human figures whose posture and position indicate organized labor. The scene is not mythological, it is operational. What makes the conventional ecological explanation insufficient is that the breed of cattle depicted, large-horned, heavy-bodied, consistent with early domesticated Bos taurus, requires a minimum of grass cover and water access that the Tassili Plateau cannot currently provide for a single season. Lot's findings were published in France in 1958 and translated into English in 1959 under the title The Search for the Tassili Frescoes. The book became moderately well known in popular archaeology circles. The version of events most people received emphasized the art's antiquity and aesthetic sophistication. The agricultural and ecological implications that a cattle economy had thrived for potentially 2,000 years in a region that is now among the most arid places on Earth, received less sustained attention in the popular record than the visual qualities of the images themselves. UNESCO designated Tassili Enager a World Heritage Site in 1982, citing its outstanding universal value in terms of prehistoric art. The ecological reconstruction implied by the art's content was acknowledged in academic literature through the African Humid Period framework, which was by then sufficiently established to absorb the finding without revision. And yet the number of individual animal figures recorded at Tassili alone, across all periods and shelters, exceeds 5,000. Whatever the plateau was during the period the art depicts, it was supporting communities large and organized enough to dedicate significant time and effort to recording it. The question that remains open is not whether it was green. It is what caused the people who lived there to stop painting. Number 8. Lake Megachad. A lake bigger than the entire Caspian Sea once sat in the center of the African continent, its shoreline visible from orbit as a faint white scar pressed into the sand. In the late 1960s, as Landsat program planning was underway at NASA, geologists studying early aerial photography of the Lake Chad Basin in Central Africa began to note large-scale linear features in the landscape north and east of the current lake that were inconsistent with the existing drainage geometry. Lake Chad today is shallow, rarely deeper than a person is tall and shrinking. But the features visible from high altitude indicated former shorelines at elevations well above the present lake surface, running far beyond the current basin's edge into what is now Chad, Niger, and Nigeria. Geomorphologist Sharon Nicholson at Florida State University and colleagues working with satellite imagery in subsequent decades confirmed that these paleo-shorelines trace the boundary of a former lake of extraordinary extent. The lake, designated Megachad in the literature, had stood at roughly 320 meters above sea level at its maximum, an elevation that would have submerged the city of N'Djamena under roughly 40 meters of water. The anomaly was the duration. Megachad persisted at near maximum extent for several thousand years, not as a brief climatic episode but as a stable geographic feature. Dr. Stefan Krpelin of the University of Cologne, who has conducted long-term fieldwork in the eastern Sahara and the Chad Basin, documented sediment cores from the lake bed showing continuous lacustrine deposition through the mid-Holocene. His team found shells of freshwater gastropods, small snail-like creatures that require clear, oxygenated permanent water, at sites that are now surrounded by drifting dune fields. A person standing at those sites today would be in one of the driest inhabited places on Earth. A person standing at those same coordinates 7,000 years ago would have been standing in shallow lake water watching pelicans. The evidence for Megachad entered scientific literature gradually through the 1980s and 1990s as satellite data improved and field surveys accumulated. The version of events most people received through popular science media described a large ancient lake, without conveying the spatial scale. Megachad at maximum extent covered an area approximately equal to the combined surface area of Germany and France. The lake's history was incorporated into the standard African Humid Period narrative and Holocene paleoclimate reviews. The desiccation event, the transition from Megachad to the present shallow remnant, was dated to somewhere between 5,000 and 4,000 years ago. The timeline was established through radiocarbon dating of organic material recovered from the exposed lake bed. The finding was not disputed, it was filed. But the desiccation of Megachad happened within recorded human memory. Communities living on its shores during the transition did not disappear instantaneously. They walked away from a retreating shoreline over the course of generations. Somewhere between 5,000 and 4,000 years ago, people watched the largest lake in Africa begin to shrink and they left. Where they went is still being reconstructed from the genetics of populations living today. Number 7. The Green Sahara's hippopotamus. A hippopotamus jaw recovered from a dry riverbed in the Algerian Sahara in 1849 was filed away in a Parisian museum for over a century before anyone fully confronted what it meant about the continent's ecological past. In 1849, French military geologists conducting surveys in the Oran region of northern Algeria recovered a fossilized hippopotamus mandible from an exposed riverbed formation near the town of Mascara. The specimen was transported to Paris and catalogued at the Muséum National d'Histoire Naturelle, where it sat in storage. The recovery was not unique. Similar specimens had been turning up across North Africa since European expeditions began systematically sampling the region's exposed geology in the early 19th century. Hippopotamus bones had been found in Tunisia, in Libya, in Egypt beyond the Nile corridor. Each find was treated as a local curiosity. The institutional habit was to explain each specimen as an outlier, a strayed individual, a flood-deposited bone, an anomaly of deposition. No single find was large enough to challenge that explanation. The anomaly was the distribution. Dr. Paul Serrano of the University of Chicago, working at a site in the Tenere Desert of Niger in the early 2000s, excavated a buried lake bed that yielded not only hippopotamus remains but the bones of Nile perch, crocodilians, and softshell turtles, an entire freshwater ecosystem assemblage, from a location that now sits more than 1,000 kilometers from the nearest permanent water. His team worked in temperatures that routinely exceeded 50 degrees Celsius, excavating with brushes and dental picks in sand that had buried the lake bed under 2 meters of drift. The fauna assemblage was consistent in its composition with the ecology of the modern Nile floodplain. The detail that made the conventional desert edge explanation insufficient was the density. This was not scattered bone but a coherent ecosystem deposit, indicating a community of large water-dependent animals that had lived and died in the same location across multiple generations. Serrano's findings from the Tenere site, which he designated Gabero, were published in 2008 in PLOS One alongside evidence of 2 distinct human burial populations. The press coverage focused heavily on the human remains, the hippopotamus and crocodile assemblage, which established that a permanent lake had existed in the center of the Tenere for several thousand years, received mention as supporting context rather than as a primary finding. The ecological reconstruction of Gabero was incorporated into the African Humid Period literature without significant controversy. The lake's existence was dated to between 10,000 and 4,500 years ago, overlapping with the human occupation of the site. The coexistence of people and hippopotami in the central Sahara was noted, and then set aside as a detail of a known climatic interval. Yet the hippopotamus is not an animal that wanders. It requires permanent deep water, submerged during daylight, grazing at night on grass. Its presence at Gabero and at dozens of sites across North Africa does not indicate a wetter than usual season. It indicates a landscape that was, for thousands of years, organized around water in the same way that the Nile Valley is organized around water today. The Tenere Desert, where that lake sat, is now the second largest sand sea on Earth. If you've made it this far and the sand is starting to look different to you, like something that was put there rather than something that was always there, hit subscribe now. More of this is coming. Number 6. The people of the Green Nile Corridor. Genetic evidence recovered from ancient human remains in Sudan and Egypt in the 2010s revealed that the population movements triggered by the Sahara's drying were so large they fundamentally reshaped the genetic map of sub-Saharan Africa. In 2015, a research team led by Johannes Kraus at the Max Planck Institute for Evolutionary Anthropology in Leipzig began extracting ancient DNA from human skeletal remains recovered from archaeological sites along the Nile Valley in Sudan and Egypt, some dated as far back as 8,000 years. The project was technically demanding. Ancient DNA degrades rapidly in warm climates, and the equatorial heat of North Africa is among the worst possible environments for DNA preservation. The team worked with material that had survived only because of exceptional burial conditions, pressing instruments against teeth and inner ear bones to reach the densest available tissue. What they extracted, when they extracted anything at all, was fragmentary. But it was enough to build a partial picture of population ancestry. The anomaly was a signature they did not expect. A genetic component associated with West African ancestral populations appearing in Nile Valley remains from a period before the Sahara had fully dried. Dr. Pontus Skoglund, then affiliated with the Broad Institute at Harvard and MIT, extended this analysis in subsequent years using expanded ancient genome datasets, and noted that the distribution of West African genetic ancestry in ancient North African and East African populations showed a pattern consistent with large-scale eastward migration. People moving from the central and western Sahara, toward the Nile corridor as the grasslands retreated. These were not small bands of foragers. The genetic signal was broad enough to indicate sustained multi-generational movement involving populations large enough to leave a detectable trace in modern African genetics. A person carrying this migration signal in their genome today might be living in Ethiopia, Sudan, or the Arabian Peninsula, entirely unaware that their ancestry includes people who walked out of a dying grassland 5,000 years ago. The ancient DNA findings were published across several papers in Nature and Cell between 2015 and 2019, each generating news coverage that focused on the novelty of the genetic extraction technique. The population movement story, that the drying of the Sahara had triggered one of the largest human migrations in African prehistory, was present in the academic papers but largely absent from the popular reporting, which preferred to lead with the laboratory methodology. The migration hypothesis was formally integrated into Holocene African population genetics models by the early 2020s, described in the literature using language like population dispersal associated with the Green Sahara termination. The phrase carries what it needs to carry for specialists. For a general reader, it describes something closer to a continental displacement. But the genetic signal is not merely historical. The populations who moved out of the drying Sahara carried with them the cattle herding practices, the pottery traditions, and the astronomical knowledge that had developed over thousands of years in the grasslands. What appeared to later observers as sub-Saharan African cultural complexity emerging suddenly in the archaeological record was not emergence, it was arrival. Number 5. The submerged stone circles of the Nile. At a site in southern Egypt that was periodically flooded by the Aswan High Dam Reservoir, archaeologists working between rising water levels in the 1990s documented megalithic stone alignments erected by cattle herders over 6,000 years ago, and then watched the water rise over them. The site known as Nabta Playa sits in the Egyptian Western Desert approximately 100 kilometers west of Abu Simbel, in a depression that collects seasonal rainfall when the African monsoon extends far enough north. In 1974, Southern Methodist University archaeologist Fred Windorf stumbled onto the site while traveling by truck through the desert and noticed shaped stones projecting from the ground at regular intervals. He returned in subsequent seasons with a team that included geologist Romuald Schild, and spent the following 2 decades excavating what turned out to be one of the most sophisticated megalithic complexes in Africa. The stones, some standing, some arranged in alignments, some set into the bottom of what had been a seasonal lake, dated to between 6,500 and 5,500 years ago, making them roughly 1,000 years older than Stonehenge. Some of the alignments tracked the summer solstice sunrise with a precision that required either extended observation or received astronomical knowledge. The anomaly was not the astronomy, it was the setting. The people who built this complex were not sedentary. They were cattle herders who returned to this lake seasonally, and they built a monumental structure anyway. Dr. J. McKim Malville of the University of Colorado, a specialist in archaeoastronomy, analyzed the Nabta Playa alignments in collaboration with Wendorf's team and concluded that the site represented a formalized ritual center consistent with a semi-nomadic pastoral society, sophisticated enough to track celestial cycles across generations. Standing at the central circle at dawn on the summer solstice, a person in 6500 BCE would have seen the rising sun slot between 2 upright stones with a precision that required the stones to have been placed with deliberate care. This was not casual arrangement. Someone had stood at this spot repeatedly over seasons and supervised the placement of multi-ton blocks to mark a celestial event. Windorf's findings were published in Science in 1998 and received wider coverage than most African prehistoric archaeology, partly because the astronomical interpretation was striking, and partly because the site was already threatened. The Aswan High Dam Reservoir Lake Nasser was expanding, and the rising water table was approaching Nabta Playa. The version of events most people received was a story about an ancient calendar. The story about a cattle-herding society organized enough to build one received less emphasis. The site was partially documented before inundation affected the most vulnerable deposits. Several of the megaliths were relocated to the Nubian Museum in Aswan. What remained in place was secured with stone casing. The process was described by the Egyptian Supreme Council of Antiquities as preservation under difficult conditions. And yet Nabta Playa is one site. Windorf surveys identified dozens of satellite settlement locations around the playa, extending over an area of several thousand square kilometers. What was documented was a sample. What was submerged or remains unexcavated beneath the desert surface is unknown. The people who built the circles were doing so at a moment when the Sahara was already beginning to contract. They built it anyway, which suggests they did not yet know it was ending. Number 4. The Garamantian Underground Rivers. Beneath the Libyan desert, a civilization that flourished 2,000 years ago built over 3,000 kilometers of hand-dug tunnels to chase a retreating water table and then vanished when the water ran out. The Garamantes were a Saharan people whose capital, Garama, occupied the Fezzan region of what is now southwestern Libya. Roman sources described them as formidable, difficult to pursue, and capable of moving large amounts of goods across desert terrain that Romans found nearly impassable. They were not nomads, they were farmers. What made farming possible in the central Sahara 2,000 years ago was an engineering system known as fagara, a network of slightly inclined underground channels, each dug by hand, that ran from high-elevation groundwater sources toward cultivation plots at lower elevations, moving water by gravity through the darkness underground. British archaeologist David Mattingly of the University of Leicester, working in the Fezzan from the 1990s through the 2010s, mapped the Fagara network using satellite imagery and ground survey and found it to be substantially larger than any previous estimate. The tunnels, laid end-to-end, exceeded 3,000 kilometers. They were maintained by a workforce organized at the level of a state. The anomaly was not the tunnels themselves but what they were chasing. The Fagara system grew progressively longer over time, each generation extending the channels further toward sources that were receding. Mattingly's survey team, which included specialists from several Libyan universities, conducted excavations at Fagara junctions and recovered maintenance debris, broken tools, lamps, ash that allowed them to date repair episodes across centuries. The earliest tunnels were short. The latest were extraordinarily long, some exceeding 10 kilometers from intake to outlet. Standing at the mouth of one of these channels, a person would have felt cool, slightly humid air moving outward from the darkness, the same air that had been moving through those tunnels continuously since someone first struck the rock 2,000 years ago. The detail that makes the conventional explanation of Gara Mansion collapse insufficient is the trajectory. The system was not abandoned suddenly. It was extended, repaired, and extended again, right up until the moment it stopped producing water. Mattingly published his comprehensive findings in a 2010 volume titled The Archaeology of Fezzan, issued by the Society for Libyan Studies. Academic coverage was substantial, popular coverage was limited. The version of events most people received, if they received any version at all, described the Garamantes as a minor desert civilization that practiced unusual irrigation. The scale of the infrastructure, comparable in total labor investment to the construction of the Egyptian pyramids, did not become a standard point of reference in popular ancient history. The Garamantian Fagara system was officially incorporated into UNESCO heritage inventories and Libyan national archaeological registers in the 2000s. Documentation was ongoing at the time of the 2011 Libyan civil conflict, which disrupted fieldwork. The status of many unexcavated sites remains uncertain. But what the Fagara record actually shows is a civilization watching a resource die and choosing repeatedly to dig deeper rather than leave. Each generation of Garamantians inherited longer tunnels than their parents had dug, and dug them longer still. The last generation to maintain the system extended it to its absolute limit and then stopped. Their descendants left for the north. The tunnels have been empty ever since, still slightly inclined, still perfectly functional with no water left to carry. Number 3. The wetter Nile. A sediment record recovered from the deep floor of the eastern Mediterranean in the 1990s revealed that the Nile River's flow during the African Humid Period was so large that it deposited a fan of freshwater sediment visible as a distinct layer across the entire eastern Mediterranean seafloor. In 1993, a scientific drilling expedition under the International Ocean Drilling Program recovered sediment cores from the seafloor of the eastern Mediterranean at multiple sites, including one positioned directly offshore from the Nile Delta. The drilling team worked from the research vessel JOIDES Resolution, lowering core barrels to depths of several kilometers and recovering cylinders of compressed seafloor sediment that functioned as a continuous archive of what had been deposited from above over millions of years. When geochemist Jean Daniel Stanley of the Smithsonian Institution and colleagues analyzed the core's Holocene layers, they found sapropels, dark, organic-rich sediment bands formed when deep water became oxygen-depleted that had previously been dated to the African Humid Period. But the cores also revealed freshwater diatom species, microscopic silica-shelled algae that live only in rivers and lakes, distributed in layers above the sapropels and extending across the eastern Mediterranean in a pattern that implied a Nile discharge volume substantially larger than the modern river's maximum flood flow. The anomaly was not a slightly larger Nile. The anomaly was a Nile that drained a continent that was substantially wetter than the modern one, and whose flood pulse reached the open sea with enough force and volume to alter the chemistry of an enclosed sea. Dr. Rainer Zahn of Geomar in Kiel, working with Mediterranean sediment records throughout the 1990s and 2000s, reconstructed discharge volumes for the Nile during the African Humid Period using isotopic ratios in the seafloor sediments, and concluded that the river's annual flood pulse during the period's peak was consistent with a catchment area twice the size of the modern Nile basin, meaning the river was receiving runoff from regions in the central and western Sahara that now drain nothing at all. Standing on the bank of the Nile at Luxor during the August flood of roughly 8000 BCE, a person would have seen a river that turned the water red for 100 kilometers in each direction, depositing sediment so thick it changed the color of the sea. The sediment core data entered the climate literature steadily through the late 1990s and was synthesized in several major review papers on the African Humid Period in the 2000s. The version of events most people received, if they received one at all, framed the Nile as having been higher during the Green Sahara period. The specific implication that the Nile's watershed had included most of the eastern Sahara was present in the academic literature and largely absent from the popular one. The expanded Nile catchment model was formalized in African Humid Period reconstructions using the buried Radar River Network, the Mega-Chad Basin data, and the Mediterranean Core records as converging lines of evidence. The conclusion was uncontroversial among specialists by the 2010s. The Nile was once the outlet of a continent-scale drainage system. Yet the modern Nile still carries traces of that system. The sediment deposited on Egyptian farmland by the annual Nile flood before the construction of the Aswan High Dam was not simply river silt. It was the last remnant output of a drainage network that once connected the Libyan desert, the Chad Basin, and the Ethiopian highlands into a single hydrological unit. The dam stopped the flood. The sediment stopped arriving. Egyptian farmers began using chemical fertilizers. The connection between the Green Sahara and the modern world was cut within living memory by concrete. Number 2. The human abandonment event. At a specific moment between 5,600 and 5,000 years ago, the Sahara lost its monsoon rains in a period short enough that it appears in the archaeological record not as a gradual thinning of sites, but as a near-simultaneous emptying of an area the size of the continental United States. In the late 1970s and 1980s, as satellite imagery became available for systematic landscape analysis, archaeologists conducting survey work across the Sahara began to notice a pattern in the distribution of Neolithic sites, camps, hearths, grinding stones, cattle enclosures that seemed to end at a particular stratigraphic horizon. The sites did not thin out gradually toward the desert's edge. They stopped. Fred Wendorf and Romuald Schild, working across the Egyptian and Sudanese Western Desert, documented this horizon repeatedly at sites separated by hundreds of kilometers. Neolithic occupation layer, sterile sand, nothing above. The break was too consistent to be coincidental. In 2002, Stefan Kröpelin's team working in the Aunianga Basin of northern Chad recovered a sediment core from a permanent lake that had survived the desiccation event, which provided a continuous record of vegetation change from the humid period through the present. Pollen analysis of the core showed a transition from grassland species to desert species occurring over a period of roughly 500 to 1,000 years, abrupt in geological terms though spread over enough human generations to be experienced not as a catastrophe but as a slow worsening. The anomaly was the scale. This was not a regional drought. It was the termination of a climatic state across an entire continent. Dr. Nick Drake of King's College London, working with remote sensing data and archaeological site distributions in the late 2000s, published an analysis showing that habitable corridors, areas with sufficient water and vegetation to support human movement, had existed across the Sahara for most of the African Humid Period, connecting sub-Saharan Africa to North Africa and the Levant. The corridors began closing between roughly 5,800 and 5,000 years ago. Drake's team mapped the closure sequence using paleolake records and paleo-drainage data, and found that the habitable corridors did not narrow evenly but collapsed section by section, like a bridge losing spans. People moving through those corridors, and the archaeological evidence suggests they were moving constantly, would have found routes that had been viable a generation earlier suddenly blocked by expanding sand. Drake's findings were published in PLOS 1 in 2011 and received moderate press coverage focused on the connection between African climate change and early Egyptian state formation. The version of events most people receive framed the Saharan desiccation as a driver of Egyptian civilization, pushing people toward the Nile and concentrating population. The version the data was telling was slightly different. It was not that the Nile attracted people. It was that everywhere else stopped being livable. The human abandonment model was integrated into both African archaeological and climate literature over the following decade. The finding that the Sahara had been populated at levels comparable to the modern Sahel, and had then been evacuated within a period of a few centuries, was acknowledged without sustained emphasis in mainstream historical narratives. But the population that left the Sahara between 5,800 and 4,500 years ago did not disappear. They carried their cattle, their astronomical knowledge, their pottery styles, and their social structures into the Nile Valley, the Horn of Africa, and the West African savanna. The civilizational complexity that appears suddenly in the African archaeological record at the start of the Bronze Age is, in substantial part, the product of communities that had been developing in the center of a continent that was about to become uninhabitable. The Sahara did not stop African civilization, it relocated it. If this is the first time you're hearing the words African Humid Period and you're wondering why, subscribe. The next video will make that question feel more urgent. Number 1. Determination. Sometime around 5,500 years ago, a feedback loop involving soil moisture, cloud cover, and vegetation began consuming the green Sahara from the north. And once it started, nothing, not the lakes, not the rivers, not the cattle herders, not the stone circles, could stop it. The mechanism was identified in its broad outlines by paleoclimatologist Peter de Menachel of Columbia University's Lamont Doherty Earth Observatory, working in the early 2000s with marine sediment cores recovered from offshore West Africa. The cores contained dust, specifically, the mineral composition and grain size of Aeolian dust deposited from the Sahara into the Atlantic Ocean over millions of years. De Menachel's team found that the African Humid Period termination at approximately 5,500 to 5,000 years ago was not a linear decline. The dust record showed an abrupt transition, low dust for thousands of years, then a rapid increase to levels comparable to the modern Sahara, within a time window that the core's resolution could not shrink below 2 to 3 centuries. De Menachel stood in his lab at Lamont looking at a core laid out on a table, running his finger along a dark stripe in the sediment, and told a colleague that the stripe represented what was, in geological terms, an instantaneous event. The anomaly was not that the Sahara dried, it was how fast. Dr. Martin Clausen of the Max Planck Institute for Meteorology published a modeling study in 1999 in Geophysical Research Letters that proposed a vegetation-atmosphere feedback mechanism to explain the abruptness. The model showed that once Saharan vegetation fell below a threshold coverage, perhaps a quarter of the land surface, the soil surface began absorbing more heat than it released, reducing convective moisture and suppressing the monsoon rains. Less rain meant less vegetation meant less moisture returned to the atmosphere, the monsoon retreated southward, the retreat exposed more bare soil, the bare soil absorbed more heat, the process fed itself. A person watching from a hilltop in what is now central Mali during the termination period would not have seen sand advancing visibly from day to day. They would have watched, over years and then decades, as the grass grew back more thinly each spring. They would have watched their cattle walk further for water. They would have watched the children born after them grow up in a place that looked subtly different from the place their parents had described. The vegetation atmosphere feedback model was published in peer-reviewed literature and generated significant discussion in the paleoclimate community throughout the 2000s and 2010s. The version of events most people received, if they received it at all, described the end of the Green Sahara as a response to a change in Earth's orbital parameters, a slow wobble in the planet's axis that reduced the intensity of northern hemisphere summer sunlight over thousands of years. That is true. What most summaries omitted was the second part. The orbital forcing was gradual, but the termination was abrupt. The orbital change set the conditions. The vegetation feedback pulled the trigger. The Saharan termination was formally described in the IPCC's paleoclimate assessments as an example of abrupt climate transition driven by vegetation-atmosphere feedbacks, with relevance to projections of future desertification. The finding was peer-reviewed, cited, and discussed at conferences. It did not enter general public consciousness at a level proportionate to its implications. But here is what the number says. The Sahara covers approximately 9 million square kilometers. At the African Humid Period's peak, a substantial fraction of that area, perhaps a third, perhaps more, was grassland, lake, and river. Between 5,500 and 4,500 years ago, that fraction collapsed. People had been living there for at least 6,000 years before the collapse. They built stone circles, dug tunnels, herded cattle, painted on rock walls, watched the stars, buried their dead in lake beds, and raised children who raised children who raised children in a place that is now the largest desert on Earth. None of that made any difference to what happened next. What we have inherited from the Green Sahara is not a mystery. It is a record. The rock art is still on the walls. The buried channels are still under the sand. The ancient shorelines are still visible from space. The genetic trace of the people who left is still inside living human beings, walking around today in cities whose names they would not recognize. The Green Sahara did not disappear without leaving evidence. It disappeared while leaving an enormous amount of it, in places we are only now learning how to read. Everything we call North African civilization, the Egypt of the pharaohs, the Carthage of the Phoenicians, the Roman breadbasket, the trans-Saharan trade routes, exists on the far side of a door that closed 5,000 years ago. What was on the other side of that door was not a precursor to civilization. It was a civilization, and the sand is still moving. If you want to see more videos like this, click the video on screen now and make sure to subscribe.